What do I mean mathematically when I say solution? Okay, it makes the equation or makes the inequality what?
True.
True, right? If it's a solution, it needs to make the equation
True.
If you were to take the time at one point or another on an assessment and substitute those values in and show, hey, this makes the equation true, do I understand or do I know that you understand what a solution is?
Yes.
So take the time to do that, right? By the way, if you substitute a value in and it says false, and you note that, hey, Mr. Kinney, I know this is not the solution because it said false, do I know that you understand what a solution is?
Yes.
So no matter what, if you get it right or wrong, then by checking it, you are showing me that you understand what a solution is. Take the time to substitute in. So for those of us who got 7.7 or negative 5.7, what did it make that equation?
False.
For those of us who got 5 and negative 3, it made the equation true. Take the time to substitute your values in and check yourself. Now, I see a lot of us working around the room, and I just want to emphasize and focus on a couple of things with this before you try D. So, pay attention to this. I'm going to put some ideas up here on the board. Use this to apply to D. Now, I need y'all to pay attention to something. What am I solving for?
X.
I'm solving for X, right?
Yes.
And so when I'm looking at this and I'm trying to solve for X, what I need to do is I need to get rid of all the stuff around the X. We all comfortable with that idea?
Yes.
Get rid of everything around the X. So tell me this, Preston, what's happening to the X first? I would say, when I look at this, those parentheses tell me X minus 1. Okay? Tyler, what's happening to X minus 1? What's the next operation happening? Say again, sir?
Square.
Being squared. Okay, so X minus 1 squared. Alright? Amaya, do you know what's happening to the X minus 1 squared?
No.
Not sure? Okay, so I'm going to come back to you on the next problem that we work on, so I need you to pay attention to this. Maddie, what's happening to that X minus 1 squared? Remember, we already said X minus 1, we already said the square. What's happening to the X minus 1 squared?
Multiply.
Multiply by 3.
Yep.
Maddie!
Come on, Maddie.
But, it's okay, I'm talking more about them, but notice X minus 1 squared is being multiplied by 3.
3.
Is there anything else there? No. Now remember, I always compare this to peeling a what?
Onion.
We want to peel away that outer layer, right? So what was that outermost layer? What's the last operation we just said?
Multiplication.
The last thing we just said was multiply by 3, right?
Yeah, multiplication by 3. Yep.
3.
So what's going to undo that? What's going to peel away that layer? Division by 3 or multiplying by 1/3. Remember, I'm not dividing by a third. I'm multiplying by a third because that's the same as 1 divided by 3. So divide by 3 in some form. And what's a third of 3?
That's 1.
You
said
third of 3 is
1.
I know.
Pick up the calculator.
Remember, we're only creating a 0 when we're adding and subtracting. So what's a third of 48? A lot of us already did this.
16.
16.
Yes.
Now, what is the outermost layer this time?
Square.
Squared. Alright? So what's going to undo that?
Square woo.
Now, I need y'all to remember, because this is what a lot of us are forgetting, and this is probably the most common mistake that a lot of students make. What is X minus 1 equal to then? Remember, right here, when you take a square root, you have how many roots? 2. I would say, when you take the square root, that's when you have 2 roots. A positive and negative 4. Can anyone explain, by the way, why we have 2 roots there?
Because you gotta both of them are it's called.
You just know I told you to do it. Alright, look. Hey guys, didn't I have X minus 1 squared equals 16?
Yes.
Originally? So tell me this, what squared is equal to 16?
4.
Negative 4 and 4.
4 and negative 4.
That's what I meant to say. They can both be squared.
I want y'all to notice,
Come on.
isn't this 4 and negative 4 in the same place as X minus 1?
Yes.
That's why I have to set X minus 1 equal to both a positive 4 and a negative 4. A positive 4 squared is 16. A negative 4 squared is
16.
16. So it's when I take the square root. The calculator doesn't know that it's a positive and a negative. You have to know that when I take the square root, hey, it could have been a 4 squared or a negative 4 squared. It could have been either one. You have to know that. Finally, what do I do to solve this equation? I've almost got x all on its own.
Add 1 to both sides.
Negative 1 plus 1 is?
Cancel out 0.
Remember, we're not just canceling things out. I know that I just showed this canceling, but you know what exponent I'm actually making this right here?
We don't know.
1.
It's actually a 1.
Oh.
When I did a third of 3, I was creating a 1.
1.
When I added 1, I'm creating a 0. When we do inverses, we're trying to create either a 0 or create a 1. That's something to hold on to. When you're doing inverses, you're trying to create a 0 or 1. Now I add 1 here. So what's a positive 4 plus 1?
5.
And what's a negative 4 plus 1?
Negative 3.
There's my x's, there's my roots, there's my zeros, there's my solutions. If you check both of those, they make the equation true. Please keep that in mind. Alright, what questions do you have about C?
Nothing.
I hope that was a good foundation so that you can access D with your group. If you are done with D, let me know. And I can give you another one, a spicy one. But let's get to it. Let's solve D for X.
Let's go, guys.
Okay. If I can grab y'all's attention on this. A couple of quick things I want to point out. Hey guys, in the back, the things I'm covering are to help you. And there is one thing that I'm going to introduce at the end. And I'll point it out, but it's something I need you to pay attention to because it's going to impact what we do for the rest of today and what we do tomorrow and the day after that. So, really quickly, I need y'all to remember, we're doing a good job of remembering to identify the outermost layer to peel away that onion. But what I want to point out here is this, okay? Hey guys, don't forget to show these are what are called the identities. Okay? Either the zeros or the ones. Now, this is the one thing I want to point out. 1/2 divided by 1/2, what is that?
1/2 divided by 1/2. 1.
Anything divided by itself is 1. So, mathematically, is this accurate? Can I or should I divide by 1/2 here?
Multiply.
Well, but what's anything divided by itself? It is
1.
and whatever you did in one side equation,
Do the other
we
side.
do to the other side. So, is this mathematically okay?
Yes.
100%. But guys, I'm trying to remind you to make your life a little bit easier. What's the thing I use every time? It starts with an R. I use the reciprocal. That mathematically was correct. However, if I do 2 divided by 1, what's half of 2?
Well, that was 2 1.
That's going to make your life easy.
Yes.
Use your reciprocal, please. It's going to make your life easier. After that, so like, again, that what she had was mathematically correct, or what this group had was mathematically correct. However, use that reciprocal. I saw several groups doing that. I just want to encourage that idea. Then do not forget, when you take your square root, how many roots you got?
2.
2.
Yes.
A positive and a negative. We talked about y in a second. One thing I do want to caution and point out here is that's actually not a square root symbol. And what symbol is this?
That's a division.
That's division. Make sure for your square root you have that little crook there, okay? That's a square root. Okay. Next, I want to talk about this problem over here, okay? I know this was the spicy one that I left to a couple of groups, but there's a couple of things we can learn out of this, Maddie. Anchor mine. I need you to girls. Okay. So, notice things haven't changed much. The outermost layer, the last thing happening is plus 27, so we subtract 27. Okay, cool. And so, I do want to point this out here because I'm going to make your life a little bit easier. Negative 3 times x minus 4 squared divided by 5 equals negative 27. And so this group multiplied by 5. Because what does this fraction bar mean? It means division, right? So we multiply, make that a 1, that's correct. And then what do they end up? Ooh, so this is actually an important detail. We need to notice 5 divided by 5 is 1. So it's not 5 times negative 3. It's still just negative 3 here.
Yes.
Okay? It would still just be a negative 3 because that 5 canceled out that division by 5. It made a 1. But what I would have done right here, I would have just used my reciprocal. This is why I use reciprocals all the time. I'm dividing by 5, so I multiply by 5. Multiplying by -3, so I divide by -3.
Whoa.
One step instead of multiple. By using the reciprocal, 5 divided by 5 is 1, -3 divided by -3 is 1. The reciprocal is your best friend when we're talking about fractions, when we're talking about using inverses, that multiplication. That that reciprocal can be really powerful. Then when I come over to this side, hey guys, what's -27 divided by -3? Anybody know that?
You said -27 divided by -3.
Dang, I can't remember off the top of my head.
That is.
Yeah, 9.
Yeah, 9.
I would say 27 divided by 3 is 9, right? And a negative divided by a negative is positive. By the way, do you have to know that off the top of your head? No, we got calculators, okay?
Yes.
However, what's 9 times 5?
45.
45, okay? And so, what we should have is x minus 4 squared is equal to 45. Okay.
Square root.
Now, we all good? We're going to take the square root at this point?
Push up.
For sure, right? Sounds familiar. So we're going to square root this. This is where I'm going to pick up, and I need y'all to pay attention to something new. Okay? First, everybody pick up a calculator. Everybody grab that calculator.
Let's pick up these calculators, guys.
Okay.
My calculator back.
Yeah.
That came with my dad.
So, I need you to find out, and trust me, everybody needs to do this because I need you to see something important. So everyone needs a calculator in hand. I need the square root of 45.
Square root of 45?
Square root of 45, yes sir.
Everybody need a calculator?
6.7.
Is it just 6.7?
6.7082.
6.7082.
So, one, I'm really glad Chelsea remembered this. Say it again.
-6.7 and positive.
So, a positive and a negative, that's one thing to
She's
remember.
smart.
2, that's not just 6.7, is it?
No,
Okay, watch this.
6.1.
wouldn't it be 6.71? Yep.
Yes.
Because you
I
have
go
to
up and I hit
round.
enter. Actually, there's even more of a decimal after that.
Come on, gang.
We didn't. You didn't tell me all about that.
Good question. Oh, I'm glad you asked this. So, 6.7 with a line at the top actually means
Repeat it.
6.7777.
But then it's gonna end up getting 6 or something.
It's just 6.7.
Well, hold on. Say again.
It's just
So, if we
repeating.
do 6.7 repeating, that's what that means. Is that 6.7 repeating though?
Not at all.
I need you to look at this again because this is actually a foundational piece to understanding a whole set of numbers, okay? When the decimal repeats like this, we call that a rational number. I'll talk about why in a little bit. If it just did 6.7 and it actually stopped at that 7, that's called terminating for that decimal. That is also a rational number. But does it look like it's repeating anywhere? No. Does that decimal, you think that decimal actually stops here? No. And so I need to make this note, and I need y'all to hear me on this, okay? Square roots, and so I want you to write this down in a minute, so I'm writing it here, but square roots of imperfect, or square roots of not perfect squares, I should say it that way. You can also call it imperfect, but not perfect squares. By the way, what are the perfect squares? What are some examples? Give me one of them.
9.
So 4, 9,
16.
16,
0, 2.
0 is 1,
24,
1 is 1. How are we getting all these numbers?
36.
I ain't gonna lie, low-key forgot because I remember learning.
45. Okay.
Hey guys, what's 0 squared?
0.
0.
What's 1 squared?
1.
2 squared?
4.
3 squared?
9.
4 squared?
16.
5 squared?
25.
So when I say perfect squares, I'm just meaning the numbers that result from squaring one of those integers, okay? Those are my perfect squares, and it doesn't stop here, it keeps going, right? 9 squared, 10 squared, 11 squared, etc. But is 45 one of those perfect squares?
No.
No. Right? If I take the square root of 16, what's the square root of 16 going to be?
4.
What's the square root of 49 going to be?
Oh,
7. But those are the perfect squares. If the square root is of something that's not a perfect square, then the number is irrational. Now, does anyone know what this prefix IR means?
Not.
Say it again.
Not.
It means not. Literally, that prefix IR just means not. So literally, we're saying it is not what? Not rational. That's what that term means, okay? Notice it's not rational. It's not a repeating decimal. It's not a terminating decimal. It is a not rational number. We're going to talk more about what that means in a second. But here is why it's important in this case. Because it is irrational, can I really write that decimal that goes forever out?
No.
No. This is what we do instead. The square root of 45. Does anyone know a factor of 45 that is a perfect square?
Nope.
Well, Carter, you said 5. 5 times what?
9.
Are either of those perfect squares?
Yes, 9.
9. So guys, when you have something that's not a perfect square,
Yes.
factor it so that you have a perfect square.
Gotcha.
Because this is what you can now do. You can split it into 2 square roots. 1 for each factor. Okay? Anyone know what the square root of 5 is? Is that a perfect square?
2.5.
Square root. Is that a perfect square?
Square root of 5?
Is that a perfect square?
Uh-uh.
No. So can I take the square root of 5?
No.
Notice it's going to be
Irrational.
irrational. So I'm going to leave that as the square root of 5. What's the square root of 9? 3. So instead of doing the square root of 45, I'm just going to write it as 3 root 5. Type in, actually let's just look at it here quickly. Alright, so square root of 45, does it equal 3 times the square root of 5? What does it say? So notice, the square root of 45, does it equal 3 times square root of 5? That's called simplifying a square root, or simplifying a radical. And so, this is actually almost easier. Are these like terms? No, so we're just going to say 4 plus or minus 3 root 5. We're going to talk about this a little bit more, but notice we're simplifying the radical. And do I have to write it out all the way from there?
No.
So simplify your radical. When do we simplify the radical? When the number is irrational. Okay, we're going to talk about that more when we get back to lunch. Please, thank you for actually taking this.
Did you get all that?
Is it still recording?
When it has-
Cut that off.
When it has
Solve this equation using the zero product property.
No.
Why not?
Wait, you can. You can.
Say that one more time. It's not in factor form. I don't have a product of zero, do I?
So you tripping.
I was just going with the flow.
Yeah. We don't have a product of zero, so I'm not using zero product property. Am I going to use inverses with properties of equality?
Yes.
Yep.
Wait, no. It's not Vertex.
It's not in vertex form.
Oh, you can't do it in a standard?
You can to
No.
some degree, but I will point this out. How many times do you see x in this equation?
2.
You see it twice. So I'm not using inverses.
You only do
Remember
inverse
that
when you got
key for all of these, how many times did we see x in this equation?
Once.
Here.
One.
Even in that spicy one I gave you, how many times do you see x?
Once.
It's when you see that variable one time that inverses with properties of equality are your best friend. Yes, Dewan.
You gotta switch that, don't it? Like you gotta turn it into a
Possible.
No. You gotta turn the whole equation into a quadratic, don't you?
What do you mean?
I mean what you call it?
What?
You can't solve it regular. Can you
What do you
solve
mean?
standard regular?
So, using inverses with properties of equality?
No, but
Is
you
that what you're
gotta
asking?
use quadratic formula to solve that.
Okay, so I need y'all to remember and hold on to this. There are 3 methods to solve a quadratic in standard form. You actually have the Fair models on them already. What are the three methods to solve a quadratic in standard form?
Quadratic formula.
Now, to solve a quadratic, remember I'm talking about in standard form. So, you talked about the zero product property, right? What form do I have to use the zero product property?
Factored.
Factored form.
Oh, can't you use area model?
So, and Dewan is correct. We could convert to a factored form.
That's what I was trying to say. I
Okay.
forgot it.
And use zero product property. I told y'all this yesterday though. I'll teach you if you want to learn how to do this. It's also on Mathia, but we don't have time to really focus on it. So am I going to expect you to be able to do that?
No.
No, but that is an option. You can convert to factored form. You can use the zero product property. What's the second option?
Quadratic formula?
Wait, no, not inverse.
So remember, if you
yes.
convert to vertex form, which we did one like that yesterday. Once you convert to vertex form, what can you use?
Inverses
Zero
with
versus
properties
of equality. Remember, the whole idea is that if it's vertex form, I see x one time.
Yes.
And then what's the third option that I need us to practice?
Quadratic formula.
Quadratic formula.
Alright. I knew I wasn't wrong.
So,
82, right?
Huh?
so
Oh.
please do not forget, you got to learn the quadratic formula. I'm not going to give it to you. It's one equation. You got to know it at this point. All the other equations we've worked with for a while, so hopefully they've sunk in. If you don't know those other equations, you need to study them. This unit, there is one equation you have to know. So, what I want you to do,
BX.
by the way,
BX.
where's that A, B, and C coming from?
Square root.
Huh?
Where's this A, B, and C coming from?
Standard.
The standard form, right?
Yeah, A times, yeah.
So,
Equal to BX.
X is equal to this when AX squared plus BX plus C is equal to 0. So, if you're going to use that quadratic formula, what do you have to identify? A, B, and C. So, that's all, we did one of these yesterday, that's all I'm going to give you for right now. What I want you to work on is B right here, okay?
Yes,
so
sir.
go to your vertical surfaces, work with your small groups to figure out B. I may bring us back together based on what I'm seeing, but the quadratic formula is there. It's in your notes, hopefully. It's also on page 85. The quadratic formula is on page 85 if you need it. But let's get up. Let's go to our vertical surfaces. That's not the only option, but it is the one I'm expecting us to learn. But I will point this out. Some of us forgot something really important. When I look right here, is this actually standard form right now? Why not? Because there's no C and there's something else. Is this okay to not have a C? Not just that. Look at this. Right here. When this is true, when what? Yeah, does that equal 0 right now?
No, it equals -6.
Guys, I pointed this out yesterday, and I need you to hear me clearly on this. To use the quadratic formula, what does that equation have to equal? It does have to equal 0. So what do I need to do to make this equal to 0?
Plus 7. Plus 7.
So -7 plus 7 is?
0.
Alright, so what's on the left-hand side of this equation?
15. Or x squared plus 15.
Come on. You with me? Plus 15x? What do y'all think about that?
Works out, yeah.
My bad.
Okay, so is it 15x or is it 8x plus 7?
15x.
Are those like terms?
No.
Remember, what this is literally saying is that I'm adding x how many times?
If that x would have been like time for work.
Correct, but this is saying I'm adding x how many times?
Unknown amount.
Well, it's multiplying, but what is multiplication? Repeated
Addition.
So how many times am I adding x? I'm adding x 8 times.
Oh yeah, right.
But then I'm only adding 7. There's no x's there. So those are not like terms. So what is A? Notice I would show what A is, I would show what B is and what C is before I start to substitute in. What is A?
X squared.
Remember, it's A is just the coefficient. What is B?
8x.
Remember, it's ax squared plus bx.
Gotcha.
Okay? C is...
7.
Okay, let's substitute those values into my quadratic formula, and let's get to it. Go. I need everybody actively engaging. Write out that quadratic formula. Use your calculator. Remember, I recommend typing just the radicand in, okay? Because that's going to allow us to recognize if it's rational or irrational or even what we call imaginary. But from here, it's just simplifying. What's the square root of 36?
6.
So negative 8 plus or minus 6, all divided by 2. Because when you take a square root, how many roots are you going to have? 2. 2. So when you take a square root, you're going to get 2 roots. And so just take the time now. You can go ahead and split it up if you want, but what's negative 8 plus 6? 2. The quadratic formula with this equation. Wait. Yes. No.
Yes, you can.
Yes.
Yes.
Maybe
It's standard.
but not right now.
Oh, you got what you call
It's in
it?
standard form, but what does it have to equal?
0.
So, does it equal 0?
Not yet.
That is set equal to 0. Remember, if I want a 0, then what is f of x?
0.
Okay. So, if I want zeros, then f of x equals 0. Or equals 0. So, now can you use the quadratic formula?
Yeah.
Not just I guess. The answer is yes. Alright, work with your small groups. Find the zeros for f of x.
I was the last one to get out.
Make sure you pay attention to that. This is not negative 10, this is a positive 10, because that doesn't say opposite of b, it just says b. Now, up to here, this is correct. Now, here is the #1 mistake that students make, and I'm already seeing it, and I need you to adjust this. Did I write this fraction bar under just part of this? No. No. Oh. This fraction bar needs to go all the way across. And that's important because this is what a lot of students do. Guys, it's not 52 divided by 2. It is negative 10 plus or minus the square root of 52, and all of that is divided by 2. The last thing you do is divide by 2. Now, from here, I need to point this out. Is the square root, is 52 a perfect square? No. So that is going to be what kind of number? Not just decimal, an irrational decimal. So remember, this is where we want to split this into these factors. 4 times 13 is what? What is 4 times 13?
4 times 13?
52.
52.
So, first off, it's 52. Second off, the reason why I found these factors, and I used these, because I could have done 2 times 26, but are either of those perfect squares? But 4 and 13, which one is a perfect square? The 4. So now I can rewrite this as the square root of 4 times what? 13. Not 13. Square root of 13. So when I look at this, I'm going to rewrite it as, what's the square root of 4? Can I do that? That's 2. What's the square root of 13? Remember, is that a perfect square? Square root of what? No. So I'm going to leave it as the square root of 13, all divided by 2. Notice, that's an irrational number and an integer. I can't add those together. Nope. But can I divide everything here by 2? I can distribute this division by 2. Alright, what's negative 10 divided by 2?
5.
Close.
Negative 5.
Negative 5, plus or minus. What's 2 divided by 2? And guys, you would just leave it like this. That's what x equals. So, what do you need to make sure you do tonight? Study. When we just say study, we mean memorize the what? The quadratic formula. Guys, you are going to have a demonstrated understanding after a couple of problems.